Hello everybody, welcome to my talk about CQRS meets modern Java. I'm Simon Martinelli, I'm from Switzerland. I'm a Java champion and a Vaadin champion. I'm also very active in the Java user group in Switzerland and in Java community process. And I'm teaching at 2 universities and I'm a self-employed consultant. You can reach me on martinelli.ch if you have any questions also after the talk. Now, what I'm going to talk about you in the next 20 minutes, I like to talk to you about client-server communication. So this setup here is very common in the last 10 to 15 years. Most of the applications have such a setup. So you have a kind of a JavaScript client written in React, Angular, or Vue, for example, that uses a certain API and then accesses the backend and the database. Last year, I was working for a client in Switzerland, and were building application for the Swiss Gymnastics Federation to capture results on track and field competitions, for example. And there we had an issue with the API. So from a client perspective, when you were looking at the code, you just saw some REST calls like get, post, put, delete, but there was no semantics. So it was very hard, and especially they were using the same DTOs for most of the requests, and it was very hard to understand the code. And what you also see in such applications is usually, I call it the mapping waterfall. By the way, the picture on the right side is created by AI, so I thought I add some AI to my talk because most of the people do these days. And what I call a mapping waterfall is like you have a Spring Boot application, for example, in the backend, and then you have a REST controller. This REST controller exposes a DTO. The DTO, when it comes in, is mapped with a mapper like a model mapper or mapstruct, for example, to an entity. The entity is then passed to a service or directly to a repository, and finally, everything is stored in the database. When you read the data, the same thing happens backwards. So you access all, again, from the REST controller, you get, for example, a GET request. Then you call the service that returns an entity. The entity is then mapped with the same mappers to a DTO, and the DTO is returned to the client. I created an example project for you. It's on GitHub. CMACH is my GitHub account, and the project is called CQRS meets modern Java. You will also find a link to the slides if you like to watch that later on. So let's go to the project first. The project is a traditional one or has a traditional one and a CQRS one. Both are Spring Boot applications. And let's start with the traditional application. We have an API here. It's called an order controller. And for example, this order controller has a get mapping that accepts a first name, a last name. It also supports paging with page number and page size. And what it does, it directly calls a finder method here on the repository and returns a list of purchase orders. Then in the code of the controller, we are looping over the purchase orders we call model mapper. So I'm using model mapper here. It doesn't matter if you're using model mapper or mapstruct in my example. Usually mapstruct is more powerful than model mapper, but it's up to you on your preference. So model mapper is used to map the purchase orders, and what I get here are entities, like we have purchase order that has a list of order items. It also has a reference to a customer, and the order item finally has a reference to a product, and the product has, for example, a name and a price. Now, the mapping is doing a mapping to a DTO, and the DTO is a class purchase order DTO that also has a customer DTO and a list of order DTOs, and the order item DTOs have a reference to product DTO. So what you see here is also very common. I say usually that this is a naive implementation, so it's a one-to-one mapping from the entity to the DTO. And so let's call this method. I created here some requests. I don't know if you know that feature, but if you're using IntelliJ, you can create a file with the file ending HTTP, and this can then be used to issue HTTP requests, as you, for example, could do also with Postman. So we have the first call here to localhost 8080 orders, and we more or less skip paging and just say, give me all data. And if I call that, you can see here in the log, it takes more than 3 seconds. Now the question is, why does it take so long? The reason for that is because of my naive implementation. I also have lazy loading in place, so all too many relationships with JPA Hibernate will result in lazy loading. And if we have a look here at the console, we see a lot of SQL statements. We have 3,000 orders, and in the log file, we have around 5,000 SQL statements. So this is the so-called N+1 select problem that we're getting here. If we have a look further at the order controller, we also see that we have the possibility to create the purchase order, and it uses the exact same DTO as we are using for reading. And again, here we are using a model mapper that will then create the purchase order out of the DTO. We get the customer and set the customer just to check if the customer exists. And finally, we save the purchase order. If we want to update the purchase order, we do exactly the same. This has some issues. So going back to the slides, I identified 2 issues with that approach. The first issue I call too much. First of all, we are probably fetching too much data. Why does this happen? Very often I see in projects that first the user interface is created and later on the backend, or maybe first the backend is created and later the user interface. So very often client and server are not created at the same time. So let's assume that we start with the backend, then we just create the general purpose API, as I did that with the purchase order controller. And now I don't know what exactly data is that is needed by the client. So I just say, I just send everything, so to make sure that the client will get every data that is needed. And that's something I call overfetching. It would be probably better to discuss that with the client developer, or if I'm a full stack developer, do it by my own and do the whole use case in one go. And then I can decide which data I really need in the front end. On the other hand, we have seen that we are sending the whole purchase order for creating and updating the purchase order, and not all data can be changed maybe. So for example, the ID of the purchase order cannot change after it is created, but in the update or the put endpoint that I have, I sent the same purchase order DTO, and this one also contains the purchase order ID, and I'm not allowed to update that. On the other hand, there can be bugs if I blindly map it with the model mapper as I do. So there is a chance that I update data that I shouldn't do. Now that's the first issue. And the second issue that we also may have, I call it too little. So what we also can have is something called underfetching. So that means not only the N+1 select problem that we have on the server side, we could also have on the client side. For example, we fetch data from the backend and realize, oh, for this screen here, we also need that and that and this data, and then we do multiple requests to fetch that. That's maybe not so bad because on the client side, we have asynchronous requests, but in the end, we could just move the N+1 select problem to the client side. And what could be much worse is if we cannot update everything that should happen in one transaction. So we would need multiple requests to the backend from the front end to update certain data. And as we don't have any distributed transactions here, this could be a problem. Now, we exactly had this problem. We also had this naive implementation because in this project, the developers that were there before us created the backend first. And they had kind of a generic approach that every entity is also exposed through a REST controller. And they exactly had this naive implementation in place. So I was looking at the better solution. And finally, I came up with an old pattern that I already know for a very long time. It's called CQRS. CQRS stands for Command Query Responsibility Segregation and means that we split the command side, so the writing side of our application, and the reading side. Now, if people are thinking about CQRS or hear the term CQRS, they always have this picture in mind. By the way, this picture comes from the original documentation from Greg Young. In the footer, you see the source. Greg Young wrote about this pattern in 2010 for the first time. Later on, it was also described by Martin Fowler. And CQRS was influenced by command query separation principle that was created by Bertram Meyer when he is creating Eiffel programming language, which says you should not have a method that is reading and writing data at the same time. So let's have a look at that picture here. We have the reading side and the writing side. And what we have here in the middle, it's called eventually consistency. We have two data storages. We would have like event sourcing in the middle, but do we really need that? And my answer, or I say, no, we don't need that. We can use CQRS as a principle to separate command and queries, but we don't need two databases. We could just be fine with one database as long as we don't have special requirements in terms of performance, for example, or availability, or redundancy of the data for reading. We can just stick to a single database. And if we do that, we could create something like that. For example, we could, instead of having a post request, we could have a create order command that is then treated by a certain command handler and is stored to the database. On the other hand, we could create a query handler that returns data to find the orders. And I created that for you. So let's have a look at how this looks on the CQRS side. First of all, let's start with the command. So the code is split into command and query. And on the command side, we see an interface called command. The interface command is a sealed interface. That's a new feature introduced in Java 17 that we can define which classes or records, in my case, can, for example, implement the interface. And I use the interface order command here just as kind of a namespace. And we will see that how I can use it in command handler with that construct. So we have create order, we have add order item, and we have update quantity command. So we don't create an order in one go, as we would do with the DTO. What also changes if you're using CQRS, you will create kind of a wizard-driven or a workflow-driven user interface in contrast to a huge CRUD interface. And so we have create order command, add order item command, and finally, if we want to change the quantity, we can use the update quantity command. Maybe you notice already, I'm also using Jakarta validation with min, max to define some constraints here. And then this command is sent to the command handler. And the command handler here has a handle method. And what I use here in combination with seal interfaces, I use a switch expression. So the switch expression has to be exhaustive. That means if I, for example, delete the last case here, my code will not compile because it doesn't cover all the commands. That's also the reason why I used these sealed interfaces. And I use records, as I said, because records are very handy because they are immutable data structures. And if I have a command is immutable, so I cannot change it after it was created. And then I just switch here over the commands. What I use here is pattern matching. So this is pattern matching for records. It's kind of a destructuring that I can directly access the attributes or the components, how they are called in records, directly to, for example, call a service method. So this is my command handle. And finally, the question is, how do I expose an API for that? And there I have two ways of doing that. First of all, I could try to do it a bit RESTful or with REST style in mind. So I will create a post mapping for the create, a post mapping for the add item, and a patch mapping for the update quantity, for example. But because I have commands, I could also have just a single method on the controller. And that's here implemented in this order command controller. This one has just the method execute, gets an order command, and directly delegates it to the command handler. If I want to use the command handler anywhere else, I could go ahead and directly annotate my command handler with the REST controller annotations. Now the question is, I get here the interface. How does the serialization mechanism, in that case it's Jackson, know which order command record it should create? And maybe you have already seen the annotation here on the order command. We can use Jackson annotation with JSON type info, define how the information is transported. In my case, I use the simple name. Simple name means there will be a type attribute in the JSON payload. I will show you that in a minute. And on the other hand, I define which subtypes we have. And if you have a look at the request, that's what I mean. So we can just post to here down, just post here, for example, an update quantity command. That is the type. So this add type attribute is defined by Jackson. And then it will try to find a class that's name is update quantity command, and that's the payload with the order item ID and the quantity that I want to update. That's for the command side. And now the question is, how can we do the query side? And for that, I use Juke. Juke is a simple library for executing SQL. And Juke consists of two parts. We have a query DSL, Juke DSL, sorry, for creating SQL statements. So it's Java with SQL statements. And we have a Juke generator that generates meta model classes out of a database into Java classes. The database could be a real database. We could also start a database with test containers, for example, or we could create the meta model from SQL files. So if you use, for example, Liquibase or Flyway as a migration tool, you can generate the meta model from these files directly to Java classes. So it's very similar if you're using JPA with the JPA model generation for criteria API and the meta model API. So it's a similar concept. Why I use Juke? I use Juke in my case because the commands usually are just insert, update, and delete statements. I don't need a rich domain model here. But if you have a domain model, you go ahead with JPA and Hibernate. That's not so important. But on the query side, I have an advantage with Juke because if I want to return nested structures, like the order has a list of items, Juke provides a so-called multi-set value constructor. And finally, we want to have a look at query side. So we have here the order repository. And here we have a single query to create purchase order. So purchase order is record with order items. We have customer inside. So it's absolutely the same structure as in the traditional application, this time with records. And we can create here a SQL statement directly with nested structures. So we have ordered ID date, we have a row value constructed to create the customer directly from the query that is mapped to a customer class. Then we have the multi-set, so that's an inner select statement that then will be converted to order items. And finally, we have the purchase order that is mapped to the purchase order. And if we execute that, so let's go to the CQRS endpoint. And this now is 3 times faster. It returns exactly the same data as before. And if we have a look here, we can see that it executes just a single statement. And then Juk also samples the output. So we have ID and order date. And let's get back to the order repository here that you can see it. So we have nested structure with the customer, and then we have the multi-set with the order item. By the way, Juk is using JSON functionality to do that. And this is very helpful because you get single SQL statements. So that's how it could look like if you're using CQRS in small. So once you're at that point, you could also go ahead and use fully CQRS. So you could introduce event sourcing. So maybe what's the difference between a command and an event? A command is always in the present. So like add order item, for example. And if this worked, we can create an event. And the event would always be something that happened. And then you have order item added as an event, for example. So a command could happen or not, and an event always happens. So to conclude, first of all, in my opinion, the separation of commands and query helps to improve the understandability, not only on the server side, but also on the client side. So you will see this if you create your access code in the client, for example, from an open API definition, you will also find these commands on the client side. And this would make it very, very understandable what happens on the system. Then it helps to avoid these two issues, so the over and under fetching, and it also can make the mapping entity to detail and vice versa completely obsolete. And finally, it enables the event-driven approach. And I just see that Jakub has a question. So how would you handle dynamic read models is the questions. If I really have dynamic read models, I probably wouldn't use Juk. I would go for a solution like GraphQL, for example.